We're going to finish up Unit 6 finally with something really simple. And this is really more for your information than for your knowledge. And don't turn off the video after I say this. I'm not going to test you on it, but it is really cool. And so all I need you to do is draw 2 sketches. And then I just want you to look at the other problems. If you look at the notes, they're really simple here. It says use Desmos to sketch. You're going to draw 2 sketches on this grid. And then it also says next, then graph these other ones and see what you think. So this is just really just for coolness factor. So this is a coolness factor video. So the first thing we're going to do is it says use Desmos.com to sketch the graph of y equals 6 sine of 2 theta and r equals 6 times sine of 2 theta. This is important, and the y and the r make a huge difference. So I've gone to Desmos. I've already set it up. So I've got over here y equals 6 sine of 2 theta, and this one is r equals 6 times 2 theta. When I turn this one on, I'm going to change to polar coordinates. So you'll want to be able to click over here. So what I want you to do is click on this. You can leave it in projector mode or whatever works for you. It's pretty busy in regular mode because it's not just, it's not really. But I've changed my grid this from -10 to 10 to -12 to 12, and this to -7 to 7. So if you want to have it look like mine, that's what I did. Nothing really major, nothing really crazy, just something simple to kind of show what's going on. So I'm going to start by turning on this one. You've seen this before. You'll notice it has an amplitude of 6, so it's going up here to the top of 6. And the period has been changed, so the period of this is, the period is, I clicked on the wrong one. The period is pi, which we would expect given this. So this, what I've highlighted right there is the period. So then it repeats itself. So it's really skinny because it's repeating itself every pi. And I could stretch it out, but I need it to look like this for the next graph. So that's cool. I'm going to turn this back off. But before I do, I'm in radian mode, and I know it says degrees over there. So on my paper, I'm going to go, okay, so it's 0 to pi halves to pi. Those are my numbers that I care about. And that's 90 and 180. So I'm going to jump over to my grid. And so I know it's 0 here, 0, 0, 0, and then right in between it's at 6. So we're going to just put 6 right here and -6 right here. We're faking it. This is a faking graph because it's a sketch. I love sketching. Sketching is the best. So we know every single one of these is going to be 0. In between, this one's going to be up, this one's going to be down, and we have a terrible sketch. Just kidding. I was about to say beautiful, and then I looked at it. I sketch. Isn't that pretty? This is what I need you to have on your paper. And I'm using my finger, so your sketch can be a little bit better, but this is really all I'm looking for. And you know this. This is not surprising or interesting. We might have not been paying attention to what's been happening over break. That's it. Going back to Desmos, I'm going to do the other one. The other one is what is cool because we know the first one. Polar coordinates are amazing. So I'm going to go ahead and turn this one off and go back in here, and I'm going to see how we have 2 kinds of grids here. We have the rectangular grid, and this is the polar grid. So I'm going to turn it on. And this is why I stayed in radian mode, because it makes more sense on my grid here. And so they do every 5 is where it's dark instead of every 3. So on ours, it's dark right here. On your grid, you're going to sketch this on that little ring, and it's dark right here, which is great. Watch this. It's so cool. So just so you know, this is our regular rectangular grid, and on polar grid paper, it looks exactly the same. It's a little bit funky, but this is what it looks like on polar grid graph paper. It's crazy. So what we have here is a 4-leaf clover. And so 0, 0, and as I go, as my angle gets bigger, you'll notice, well, if you remember, this gets taller, right? The angle gets bigger, this gets taller. And it gets back around and loops itself, right? So these are the loops that are being created, and I think it creates it something like this. And I tried to get a way to trace around this and have it do it by itself, but I couldn't get it to work, and I tried really, really hard. So I'm not 100% sure about how it goes, but again, this is just for information to go, wow, that is cool. So what I need you to do is really straightforward. At 45 degrees, it's not giving me that grid, that point. At 45 degrees, we're all the way at 06, which makes sense because that was our peak at pi halves and 45 degrees. And so, and then we're at zeros. in between. So these are our peaks. And then it just repeats itself over and over again. It's amazingly awesome 4-leaf clover pattern. So now I'm going to go back and graph it. And so we have a 0 right there, you know, and then at pi halves right there is the peak of my loop. My other loop is right there. Next loop is here. Last loop is here. And again, wait, those are far enough out. Excuse me. There and there. And again, you're not required to know how to do this. I just want you to go, wow, neato. This is all I'm looking for is a wow, neato. Did I get a wow, neato? This is what I care about. And I'm doing it this way because I think that's what it does. And there you go. There's my loops, and I missed that dot, but that's all I need on your paper. Now, what I want you to do is go to Desmos and try these ones in both rectangular and polar grids. So when we do rectangular, we're going to use Y. When we do polar, we're going to change that to R and see what happens. So cool. So pause and go over there and try them, and I'll show you them in a minute. But I want you to go try them because they're amazing. Rectangular ones on, you know, whatever. They're boring. There it is, and there it is. Neat. Okay, I'm gonna turn this one off and go back to my polar grid for just a minute and turn this one on. Isn't that cool? And so we have 3 loops, so now I've got a 3-leaf clover. It's because it's odd inside, just so you know, that's what's happening. When it's even inside, you get even numbers of loops. When it's odd inside, you get odd numbers of loops, which is just pretty dang cool. So just in case you think I'm pulling your leg, I'm turning this one back off. Just for the sake of fun in it. See, look, 5 because it's 5 inside. 6, that's 12. So it doubles when it's even. So 2 was 4. And I know you saw that for just a second. 2 was 4. 3 was 3. 4 is 8. 5 is 5, and so on. And it's just cool that it does. I think these are the coolest graphs. And how much are you required to do? Basically nothing, which is pretty cool too. So then just gonna switch this off. Turn this on. So we've got our wavy thing. And notice it's kind of shifted up and just a little bit below the axes. And look what happens. Notice there's nothing inside with theta. So it's 1. I got a loop. I don't know what this is called, but now it like looped inside itself, which is pretty cool. And this 2 moved it up and the 4 did something. So if I take the 4 off, there's no loop. If I put a 5 there, it's a bigger loop. Right? And if I put a 7, bigger loop. So see how it's just getting bigger and bigger? If I put a 3 there, just a tiny little loop, a 2, it's not even really looping yet. It's just kind of dimpling, I think they call it. Polar graphs are just so fun. And again, you don't have to know them. I just wanted to show you how amazing they are because this is really, there's some really cool applications to these that I don't actually know. I just remember drawing them and going, ooh, neat. So that's all you need to do is ooh, neat. You don't have to be able to recreate them. It's just for fun. This is a purely for fun video. I hope you had a good time, and I will see you soon.